Delivery, operation, and maintenance, additional support materials are going to be needed depending on the delivery. It's just like any other laboratory. If you don't have curriculum built out around that laboratory, the laboratory is not going to be used. So, working with those faculty, getting a faculty to champion using your laboratory, again, it's just like any other piece of curriculum material. You could have the best textbook in the world, but if it's not adopted, it's not going to happen, or the best widget. If the faculty doesn't pick it up, get the assessments, roll it into what the objectives of the course are, it's not going to work. Physical maintenance, again, having an O&M plan ongoing for these labs. Our power grid laboratory, we're scheduled for a 1-month outage in June this year because the manufacturer of the motor generator sets does not make the brushes. We have to send the motors out to be refurbed and have custom brushes made. So how does that impact your schedule? Infrastructure maintenance. I just mentioned we just moved the lab infrastructure to our virtualized campus servers. So we now have the room to scale. How do you want to work those agreements to make sure that you have what you need to go forward? And scheduling. Online labs will require scheduling, and the ease of your scheduling system should match the ease of use of your lab. If the lab is really easy to use, but the scheduling system is a nightmare, it's going to impede your students from using it. So we've done a lot of work on scheduling, and as I mentioned, we're currently rebuilding our scheduler right now to be more user-friendly. A couple examples just to show you what these look like. I will pull up our newest laboratory is our wind laboratory. We have a 2.4 kilowatt wind turbine on campus, and what you're looking at is the real-time screen. What's unique about this laboratory is there's no control. This is data telemetry gathering only. But what you're seeing is, for once, it's actually nice in Bismarck. It's 15.4 degrees out. We have a 5-mile-an-hour wind, and the generator is currently not producing. But one of the unique things about this lab is we do have a historian, so we can pull any archive data. For example, if we want to look at average power, average RPM, average wind speed, and average temperature for the last, since midnight in 10-minute intervals, we can pull that data up. We can look at that hourly since the 24th of February, and we can go back even farther. We started archiving in April of 2010. So just a quick example of how we use this remote technology. You can see how quickly that loaded. The very, very small interface, very lightweight. Another quick example for you is our process technology laboratory. Again, this is the one I mentioned that uses the fluids. This is a photorealistic view of the laboratory. She's going to start up for me. We also have the P&ID view. This is what our industry folks would see. What you're seeing here, all these data points, you see things moving around, those are real-time updates. We're 1 second delayed from real life. So if I open valves, and I'm going to very quickly go through this. If I open valve and set controls, this is a PID control, for example, with a pneumatic valve, and start pumps, you'll see this act and react in real time. So everything you see moving and changing are real-time measurements. We're about 1 second delayed. And if you look at the vessel on the in the upper left, you can actually see it starting to fill up. That's real water filling that vessel right now. That laboratory is located in a secure location, floor below me. That brings up another good point, is since these labs book 24/7, how do you handle and start and stop automatically? How do you ensure that they're safe, that students can't get to them, that there won't be issues and things like that? And the last one I'm going to bring up for you is the power grid laboratory. This one is unique, and one of the things I love about these laboratories is not only is it real hardware, but these are also analog simulations. And when I say an analog simulation, in this example, we have 2 hydroelectric power plants controlling a small power system. Now, when I say analog sim, what I mean is we don't really have a hydroelectric turbine downstairs, or 2 of them. We have 2 DC motors running those generators. And we use a software model to mimic the hydroelectric. So it's a software model mimicking a hydroelectric running a physical AC generator connected to the rest of the system. So being able to use such things is very unique. And as I mentioned before, we also do have cameras. I've gone ahead and I'm starting up one of these generators. Got to get my auxiliary started. I'm not a very good power plant operator, as you can see. So what you're looking at here is real-time operation of a miniaturized power plant here in Bismarck, North Dakota. And you'll see this generator start up here in the corner. All right. So this is a little bit about what we're doing here at Bismarck State College, National Energy Center of Excellence, as well as lessons we've learned. A lot has gone into the interface optimization, the bandwidth optimization to make, because ultimately this comes down to user experience. If the user doesn't have a good experience, it becomes very difficult to make these laboratories work. A couple minutes left. I'd be happy to answer any questions you have.
Well, thank you, Dr. Allen. Very interesting presentation.